Okay, this is Devops Logique. So, many years ago, I was on a site called infrastructures.org, which talked about infrastructure management. We're going back to like 2004 or so. There was a mailing list attached that I hung out on. At that time, the state of the art was basically CF Engine and BCFG2, which were, I mean, they worked, but they were kind of ugly. So some of the guys on the list came up with this thing called ISConf. ISConf was fascinating because it was gold image only. It had only two commands. You could do snap to make sure a file was available on disk, and exec to run a command. So they'd start off with a gold image, run a bunch of commands, and then save that off as a gold image. So they always knew exactly what the machine had on it. The disadvantage being, if you made a mistake at any point, you restored your gold image from backup and started again. It was kind of the AWS approach to systems automation, except done back in 2005 on more hardware. Turned out to be really useful to them because they had a financial customer with an office in the Twin Towers. So when the customer's main office fell down and went boom, they were able to get everybody up and running again at a secondary site very easily because all of their machines were completely predictable. It's kind of fascinating. And then a guy called Luke Kanies was on there and went, I've got an idea for how to do this better. I'm planning to call it Puppet. And we're starting working on that. And that Puppet obviously is a lot more, you know, trying to deal with various aspects of a system and writing out specific files so you can run it on a machine that doesn't have an absolutely known state. A couple of years later, on Catalyst IRC, I was talking to the guy who wrote Catalyst Action Rest, and he was saying he built this Catalyst app at his old employer, a guy called Holloway, that was single copy Nirvana, because he had, for every config file on his system, he had a Catalyst endpoint, and he would basically do a get on the endpoint and write that out into the config file. And he'd been really enjoying this. And he was now working on a design for a replacement. The sad part, and he spent quite a bit of time swearing to me about this, was all of his customers at the time, he was a sysadmin. His customers were all Rails startups. So in order to be able to sell it to them, he had to write his new automation system in Ruby. You may have heard of it. It's called Chef. So yeah, this, by the way, is why Chef have been non-dogmatic about Ruby. Rewrote the core server in Erlang. It was originally written by a Perl guy who only used Ruby because he had to. So, you know, writing something else because that works better? Fine. Anyway, the thing that annoys me about systems automation tools is that they always want to feel like they own your system. And that's all very well, but consider dev boxes, right? On a development server, sometimes you're going to want to do something like add an extra line to the host file temporarily for testing, yeah? It is the worst thing in the world if halfway through your testing, your configuration management comes along and stamps on the host file. So what that tends to result in is people don't run full configuration management on development servers, at which point your development server is less similar to production than it might be, and this has always annoyed me. The other thing that really drives me batty about this stuff is basically make -n is a wonderful thing, right? Make -n means you can see exactly what the tool is going to do before it does it, so you can check it for problems. And you can also do beautifully insane things like, I need to add a compiler option, I don't understand this make file, I need this built now. Fine. Make -n, pipe pill -pe, substitute regex, pipe sh. And it works. It's not pretty, but if you need it built now, doing that, documenting it, and going back and fixing it later is really helpful. The other thing is the idea of new versus old file contents, right? DBIX class schema loader gets this right. When it's about to rewrite a file, it checks the MD5 hash to see if the file is what it wrote before. If so, it knows it's safe to overwrite. If not, it goes, what have you done to the files? Figure it out. So blind overwriting has always seemed to me like a bad idea. What I want is a systems tool that asks, is this mine? As in, did I install the current contents of the file? If so, it's safe for me to overwrite it. If not, somebody who is root changed this file. A configuration management system should not assume that it knows better than a sysadmin with root. Because, yeah, the configuration management is supposed to be a tool of the guy with root, not a thing that forces him to do it their way. And it's always struck me, there's no reason you can't actually have tickets as part of your automation system. So if it goes, I don't know what this is, its action is, rather than overwriting anything, it raises a ticket in RT for a human to come and figure out what was supposed to happen. So trying to figure out this stuff, I ended up looking at a thing called Nix. Nix is fascinating because it's a pure functional build system. It basically builds everything into a directory identified by package name and then a giant SHA-1. Nix was relying on SHA-1 never colliding before Git made that cool. It's beautiful. The problems that you have are, obviously, you have to buy into the Nix way of doing things, and also it still requires a channel, as in a supplied set of versions of the software, so it will always install from those versions. So you've still got the limitation of somebody has to manually curate that channel. And it seems to me that shouldn't be true. Dependency resolution it's an interesting problem, but, okay, you have X needs greater than 1.1 of some dependency. And then Y needs greater than 1.0 of it. Well, that's easy enough. 1.1 satisfies this. Now, what happens if there's a bug in 1.1.12? At that point, if 1.1.12 is the newest one, all current systems will either install that and you'll end up with a broken install, or they'll go, there is a conflict here, error, human, please fix this. And that just seems sad to me, because given there's conflict information in things like meta.json, you should be able to detect it and just go 1.1.11 will work. But nothing does that. The other thing I ran into as a problem is most packaging systems don't deal with the idea of multiple copies of the same package installed at the same time. And I want to have multiple versions. If I have 2 Perl applications running on a system, I want them to have their own set of CPAN dependencies, because if I'm upgrading one, I don't want to touch the other one that is working fine and hasn't been changed. I mean, that seems like it's not much to ask. This is why what I end up doing is shipping a local lib alongside each application. DPKG really wants to own slash, which, well, it's fine, but I really wish it would handle multi-copy. The thing is, the DPKG developers, somebody suggested multi-copy to them several years ago. The person suggesting it was an idiot. He said, you should add multi-copy. And as a result of adding multi-copy, you should rename every package in Debian to this better naming scheme I have. So when I go to the DPKG developers and talk about, would you be interested in multi-copy, they go, no, clearly it's a stupid idea. Because this guy basically made the idea toxic to them by being stupid about everything else. Open source is made of people. I do understand why they felt like that, but that meant DPKG was not really, Amusingly, RPM can handle multiple copies of the same package installed at once, which is absolutely fantastic, except, it handles it. It works, but it's RPM, so everything else sucks. So, no. I also stumbled across this thing, BPEL, giant XML standard that never got popular outside of big enterprises. The sort of people who thought SOAP was all right, but it could do with a few dozen more features. But the idea of BPL was it was an orchestration language that would deal with choreography across multiple services. And because those services, you couldn't do two-phase commit on a lot of enterprise SOAP services, it had the idea of a compensation action. So if something went wrong, you could actually encode, and this is how you do a manual rollback, which I thought was really clever. But anyway, so going back to -n, Haskell. Looking at various stuff on Haskell, monads are actually a way of enforcing that. If you think about it, the top level of a Haskell program is a single I/O monad, so you have to have all the I/O at the top. So all of the decision-making is pure functional, and then you get a final I/O approach. And the way monads basically work is you have a function that takes a state of the entire world and returns the new state of the entire world, conceptually, which is potentially really interesting. So then I fell into looking at Prolog. Yeah. Designed in the 1970s by crazy French people, always fun. They come up with such strange names for things. There's a theorem prover that I'm currently reading that was, again, designed by some French people. And it's called COQ. It's like, yes, thank you, French people. I now have to explain to people I'm reading a book about cock. But the idea of Prolog is you have a predicate, right? And that's talking about truth. So if you call that with the server bound, a value for server, but a free variable for package, it will tell you all packages on the server. You call it with a package, you'll get all of the servers the package is installed on. If you call it with values for both, you get true or false depending on whether it's installed. And the idea of having a single expression that goes in more than one direction seems really interesting. Because the idea of Prolog, it's a logic language rather than an imperative language. So it expresses truth and tries to look for a set of values for which the requirements you've given it are true. So it's basically a proof seeker. So if you say to Prolog, find me, I don't know, a server that has these three things installed on, it will go and it will basically check and it will return one result per server that it can prove matches all of those requirements. And then, just for more languages, TCL. TCL is so misunderstood. It's actually really nice. It's basically Lisp, except instead of made out of lists, it's made out of strings. So it's kind of Lisp for system scripting, seriously. Like, the first thing I did when I got to TCL was I wrote if not and went, hang on a minute, I'm a Perl programmer. I want unless. Turns out it's about 5 lines of TCL to implement it, because braces in TCL are actually a single quote, right? So that is actually a block being passed to the unless procedure, and then I just test the thing, and then eval the block if valid. And that actually works. A lot of TCL's control structures are basically built up out of passing blocks. Now, this sounds like it's string eval all the time, but basically, after the first time it compiles a particular string block, it caches the script version. So the efficiency is fine. I have spent quite a while reading through the source code to the TCL VM, and if anything, it's slightly less scary than the Perl internals, but it's very much a language in the same class. And of course, inevitably, there was going to be Perl in this, because Perl is the Swiss Army chainsaw. Alternatively, I mean, Luke Caney's went from Perl to Ruby for Puppet because he couldn't get nice enough OO out of Perl back then. Well, you know, now we have Moose and Moo. So, frankly, Perl for me is like Ruby, except with OO that works. You know, because every time I try and write OO code in anything else, I end up missing Moose. Actually, it turns out there are Ruby people who also miss Moose and have started re-implementing it as a Ruby extension. Python, I have no idea. I am trying to encourage some Python people to steal it, but...
2 implementations.
Yeah?
Bullwinkle and elk.
Right. I shall update that. Remind me afterwards and I'll update the slide. So back to make. Okay, I hate tabs. This is the classic example of backwards compatibility gone wrong, right? The guy who wrote make realized tabs were a bad idea about a month after he first implemented it, but he had 5 users and he didn't want to break their make files. Seriously. Pretty much the biggest regret of the guy's life now, not breaking those 5 people to get rid of the tabs. But make is still awesome because it's simple, it's obvious, you can ask it what it's going to do. That makes it very easy to debug, and of course, because you can make one step, if that works and the second step breaks, you only have to debug the second step and can then rerun that, which makes it much easier to have complex multi-step procedures and debug them at a decent speed. And plus, because of -n, it's completely predictable. Final thing being, because it's all declarative, the result of a make is basically reproducible. If you wipe everything, check out fresh again, and run make again, you can expect to end up exactly where you were. And again, I think current systems don't realize how important that is. So yeah, the reaction when I talk about this is often, you're using what? Because, Perl people, by and large, don't get TCL. TCL people, by and large, don't get Perl. Haskell people are just disappointed that not everybody understands Haskell enough to be in love with it. And Prolog people, wait, there are Prolog people? I eventually found a channel on Freenode with 5 of them. And the great thing about the Prolog people is, so many people are so disturbed by Prolog that when I went, oh yeah, I'm using Perl, and they're like, well, if you've got as good a reason for that as we have for using Prolog, we're not going to argue. It was really nice. Because everybody goes, Prolog is weird and scary. Prolog people don't consider that to be a criticism of the language. Makes them really, really relaxing to work with. Anyway, so my idea was to build something that isn't just a prover, but a solver. I'm going to have to explain that. That's what the second half of the talk is for. So what do I mean by a solver? I look at the idea of starting off with almost an equation that describes what I want. So I say that for an environment that you're going to execute code in, to satisfy a requirement, means there must be some build of a package that satisfies the requirement, and the environment needs to contain that build. Fairly simple, yeah? But then you have the thing of those things themselves have dependencies. So what you do is make it recursive. For each requirement of that build, you also need to satisfy that requirement. And that's what follows the dependency graph. And so I was looking at this because I'm interested in deployment systems and whatever out of this. And then the output from that, okay, standard thing in Prolog, you either get, here are a set of values that make this true, or no, I can't. I, on the other hand, have a system that can say true, false, or maybe. Okay, there is a good reason for this. Because what it means by maybe is false, but. As in, false unless you run these actions. So it can give you possible solutions. As in, if you say, is Apache installed on this server? It can say, no, but if you run apt-get install Apache 2, it will be. Yeah? So you basically get, instead of where Prolog just gives you a set of values, the solver I'm working on gives you a set of values and zero or more actions required to be run to make it true. And because the actions all have to be returned to the top level, in the sort of I stole this from Haskell monad style, that means you always have -n, because you can always print out what the actions are without running them. And so basically the values at that point are a projected result, and if that looks right, then you can tell it to resolve, where basically what it does is it runs any actions that don't depend on another action. So for example, if you have a situation where you have a create directory action and then an action to create a file in that directory, the create file action depends on the create directory. So what it does is runs the create directory, then reruns the solution process because it doesn't trust that the create directory worked. This is systems code. It does not trust that anything went right, especially when the code that did it was written by me. This is the correct attitude to systems code, I find. You know, always be as paranoid as possible. So run the independent actions, rerun the solver, find out what independent actions you have now, rerun, and keep going until the solver just returns, here's the values, true, no action required. So in order to experiment with this, I decided to write an SSH key manager, which obviously I called key mangler, because what else are you going to call it? So the idea is I can define a rule saying on a given account, find the home directory, say that there needs to be a directory called .ssh in there, and it needs to have these permissions. Yeah? And then if it's not there, then that will trigger an action of create directory. If it's there but the permissions are wrong, it will trigger an action of chmod directory. And then on top of that, you can build a rule for the authorized keys file that says it has to be in a valid.ssh dir. Shame I can't spell the file name, but never mind. And that builds that, at which point you can then build on top of that and say, is a key installed on an account? Well, that means that the authorized keys on that account pull the key file and assert that the key line is in there, yeah? And contains line will return true if it's already installed, and if it's not, it will return an append to file action to go and actually write the key into the file. So what you end up with is, for a fresh machine, it generates just two actions. One to create the directory with the right permissions, one to create the file with the right permissions. If it's already there, it can go and generate a rewrite file action that will just append. But the interesting thing is, I was thinking about configuration for this. I thought, well, why don't I just make the configuration text files with the keys and hosts in them, one per line? As soon as you do that, you can build the config handling out of the same thing. So my config file, type of config file, goes and figures out which config file it wants. Inside there, it's looking at, does tilde.keymangler exist? Which means when you first add a config entry, the solver automatically figures out it needs to create its dot directory and just does it. I don't have to write any code for that. It just figures it out by the sense of, I say the directory must exist. And then we can use contains line, and if we give it a file and an unbound entry, contains line will match once per line in that file, which then ensures that each key is installed on the far end. So I'm managing to use a small number of primitives to build a bunch of stuff. And then the system has three modes. Query, solve, and ensure. The reason is, query is this true? So if you want to do sort of status information, what's currently installed where, you run query. Query means actions are not allowed. So it only checks the state of the world. Solve is you are allowed to generate actions, but you must return them. So solve basically gives you, here is what the world should be like, and here are the actions I'd run to make it like that. And then ensure basically wraps solve in a loop, doing the run actions and run actions and rerun, until it gets the world to the right state. So what I can do is I have a file called keys that's pulled in via the contains line. So you have a routine called known key that reads each key from that file. And then I'm literally saying, for each known key, make sure it's installed on this particular SSH account I can get to. Yeah? And I can use that to test whether all of the keys are installed or to drive installing the missing ones. So status is basically, for each account, I run that and print out the results. Sync is for each account, I run that under an ensure. So, okay, we want -n. -n becomes trivial, because the code for sync just looks like solve all keys installed, right? That's sync -n, and then if you haven't supplied -n, instead of calling solve, it calls ensure, and that does the key installation. Basically, because of Prolog handling truth in either direction, you can sort of flow back and forth. In fact, the subcommand for add key is literally, it runs the same myconfig thing, but contains line with the key bound, and in the same way as contains line for authorized keys will add a line to the file, the contains line on the config file adds the line to the config file. So, you know, going both directions is a single piece of code and a single set of underlying concepts. So coming back to this, if you have this situation, okay, it's building them up gradually. But if you're in this situation, Prolog, because it's searching the space of possible solutions, has a thing called backtracking. So if it hits a clash, all it does is goes, okay, 1.1.12 did not work because I've hit a clash with the requirement further down. Roll back, try the next possibility, and the next possibility, of course, will be 1.1.11, which works, at which point it runs through. And you get a consistent set of dependencies without having to hand curate a set. And so similarly, I can do automation with this for a host file, where I assert that the host file contains all of the correct lines, but because it's only caring does it contain the line, any other lines that have been added will just be left alone. I've been working with Ingi on a PegX parser for JSON that keeps all of the white space information. So I can basically poke a single value into a JSON file and have it save out in a way so that if that JSON file lives in a repository, your diffs still look right. And this idea of only matching on the things you specifically care about and leaving anything else on the system alone means that you can write things that work even in an environment where you don't own anything, right? You know, the key manager, I'm running to update SSH keys on all sorts of customer systems and all of Shadowcat servers. And I don't need any cooperation from a sysadmin because literally what it does is SSHs into the remote machine and runs Perl on the other side using a module called Object Remote, which I will be doing a lightning talk about that later. So the source code is in Git. The internals are a little bit on the evolved side at the moment because basically I am trying to build a language and understand how to use the language at the same time. So I'm not claiming I'm yet that good at either of them. And I suspect I will end up rewriting the internals at least once more before I'm happy with it. But if you want to have a play with what's already there, I am actually using that key manager thing live because I wanted to force myself to dog food as early as possible. And I think potentially this is going to produce a much more flexible and powerful configuration management approach than any of the current stuff. And you know, it would be really quite nice for there to be a configuration management system that people loved that wasn't written in Ruby. So, you know, see how far we get. By this time next year, I hope to have a sort of a fully running system on this. And I'm giving the same talk at YAPCNA, and I'm planning to force myself to have a better example than the key manager by then. But I think fundamentally, Prolog and the idea of logic languages, in the same way as Lisp kind of got ignored for decades, Prolog gets ignored, and there's a lot of interesting ideas to be had from learning it. There's a lot of tutorials online, and SWI Prolog, the main free software implementation, is actually very good. I mean, because I'm doing weird stuff, I've implemented my own in Perl. But anytime I'm not sure if I've implemented it right, I go and run the same code at SWI Prolog's prompt and make sure it does the same thing. So I'm kind of using it as a live set of test cases. And yeah, I'm afraid that's basically it, because it's still work in progress. But hopefully I've given you some ideas. And hopefully this is a way to sort of think about how you're managing and deploying things that I think is better than the I own this file smack brute force approach that's currently taken. Because actually defining what you want and letting the system only produce that is much more likely to do what you mean. So yeah, thank you very much. And lo and behold, the timer says there are several minutes left, so does anybody want to ask questions?
How would you deal with circular dependencies, which shouldn't happen, of course, but happen?
Ideally, if you create a circular dependency, a small gnome will climb out of the back of the computer and hit the developer with a hammer. Interestingly, it is possible to handle circular dependencies on CPAN modules. What CPAN Plus does is it unpacks both of them, runs make on both of them, and then tests them with both sets of blib in @inc. But having seen this in action, I have concluded that's a terrible idea. If you find a circular dependency, you send a patch. However, this system should be able to detect a circular dependency and basically complain. And because of the way rule matching works, basically you can have several rules that are a way of resolving something. So what I'm intending to do is you have a basic fallback rule, which is just build this in the normal way for a CPAN distribution. But you can register rules that run before that are specific overrides that act kind of like the pref stuff in CPAN.pm, so that you can say, do a normal build except with these things changed. So you can inject a missing dependency or remove a mistaken circular dependency or whatever. Because of the idea of Prolog being run an action, this being run an action, recheck, run an action, recheck, the idea is if make fails but configure succeeded, you can get a directory with configure done, look at it, tweak it, and then try rerunning the make phase. So trying to deal with, say, build failures, you don't have to rerun the entire build from the start to see if you fix the problem. Anything it's already done that was independent of the change you made is still valid and it'll still use it. Because being as, when Shadowcat first encounters a customer, you know, we're usually brought in to do, yeah, Catalyst, DBIX class, Moose, I turn up, go, yeah, and your deployment is stuffed and you don't have a proper staging environment. So while the Shadowcat team gets to actually write Perl, I get to rebuild their systems automation. So there is a great thing of, I am very much aiming for this will be easy and fast to debug things like build failures, because I'm likely to be the one debugging the build failures and I want it to be easy and fast. Anybody else?
Just to get back to this question about the circular dependencies, key mangler, it's actually much simpler. You can have a circular dependency when you say check whether I have my key on this account, and in order to get into this account, you need to have the key there already. How do you deal with that?
Oh, well, that's really easy, because when it first tries to log into the account, it's doing it with Object Remote. Object Remote runs SSH attached to your terminal, so you'll get a password prompt. So you do km sync name of account, it tries to SSH in, you get the password prompt, type your password in, hit enter, it now has an Object Remote connection, at which point it can push the initial key for you. Yeah, that bit basically just worked because of Object Remote being built the way it is. Object Remote was, among other things, always designed to be a transport layer for this sort of code. So its current main deployment is for a customer of ours where basically once a day it logs into all of their production servers and records every package installed, every process running, every network connection, and commits those to a repository using a thing called System Introspector, which I have in Git. It should be on CPAN, but we got it deployed in production for the customer that sponsored it and never quite got time to finish it. Basically, the idea of doing that en masse is expected. And we already had simple Object Remote scripts that were designed to get the initial key setup done. In fact, that was part of why I started working on this, because that customer had like 3 machines managed with Puppet, and then everything else wasn't. It's so much fun when developers build the platform and then get fired for being idiots. This is why we have code that goes and figures out what's installed on the machine, because the customer's new sysadmin needed to know, and nobody actually knew. Yeah, that was where I started getting really annoyed, because I'd add appropriate config entries for the introspection stuff, and then 10 minutes later, Puppet would come along and stomp half of my changes, but only on the machines where Puppet was running. And at this point, we didn't know which machines Puppet was running on. This is why I believe configuration management, if it sees something it doesn't expect, should go, I'm not touching this until a sysadmin tells me what's right. Because systems that don't have caused me so much pain. The worst one, obviously, being if it's 3 in the morning, your pager just went off, production is broken. I don't care about the configuration management at that point. I want to get production back up, document what horrible hack I did, and go to bed and fix it properly in the morning, right? Whereas if you've got a Puppet-style environment, you hack it until it works, document it, and just as you're getting into bed, the pager goes off again because Puppet broke the system for you. Because it rolled back to the unfixed version. No. Do not want. Okay, time for one more, I think.
Is the Prolog-like work going to be exposed enough outside of the system so we could reuse this for other logic programming problems?
Yes, although I am not aiming for it to necessarily be that performant as a Prolog, merely as a way of approaching this style of problems. It would probably need a fair amount of work to be a good Prolog, as opposed to just being a component of this system. But yes, absolutely. The rule syntax I showed you, just a second, that is actually executable TCL code, where I've defined a bunch of TCL procedures. But what that then does is it's embedded inside Perl using TCL.pm, and the TCL code calls back to Perl and builds up a data structure that's basically nested array refs. Kind of an S expression of a Prolog expression, and then feeds the array refs to the Perl code. So it's absolutely fine to be able to call the solver independently from inside a random Perl script. Most of my tests work like that. The TCL stuff is purely a nice DSL scripty front end that eventually calls first-class things on the Perl code. Because while I suspect that TCL is going to be, that this is going to be the nicer syntax for treating it as configuration, from the point of view of people who want to be able to use the solver to drive something within other code, obviously it has to be first-class callable from Perl as well. I mean, obviously, like making nested array refs out of that isn't quite as pretty, but it does work fine. And I am out of time, so cheers, and if anybody else has questions, ask me sometime on the floor or down the pub.